Hey everybody, in this building block video we're looking at potentiometers, little dial resistors, so grab those from your kit and let's dive in. Potentiometers, new part, and as always we're going to explore new parts with a little bit of information about them. What does a potentiometer or a pot want? So a potentiometer is a variable resistor, and what it wants to do is alter the flow of voltage and current. And it achieves this by changing resistance. And remember, voltage, current, and resistance are linked to each other through Ohm's law. If you look into the upper left-hand corner, you'll see that there's 3 pins on a potentiometer, and we label those, just for argument's sake, left, L, W for wiper, and R for right. So you've got a left leg and a right leg and a wiper in the middle. And that wiper is attached to the dial part of your potentiometer. Schematic symbol below is left and right, so it's just a basic resistor, but then it's got an arrow pointing down at the squiggly line. And you can imagine that arrow moving left and right, if you like, while you dial the potentiometer, and that's what that's supposed to indicate. So we'll see some uses of that particular component in schematics. So as you turn your dial from left towards right, you change the amount of resistance between the left leg and the wiper and the wiper and the right leg. If you dial this all the way to 0, it will not offer any protection. So you can't use a potentiometer on its own as a current limiting resistor with an LED, because if you dial the resistance to 0, you effectively take the resistor out of the circuit and you blow up that LED. And we're going to look at that in just a moment. One other important technical note, a potentiometer is also an example of something called a voltage divider. And voltage dividers, like their name suggests, split voltage. So when we hook this up in a circuit, we're going to connect one of the outside legs here, left leg to ground, right leg to positive voltage. And we're going to see as we dial the potentiometer that the voltage at W on the wiper leg in the middle varies as we alter the resistance. So the resistance is changed directly by the component. It's a variable resistor, but the impact is felt in voltage and current flowing in the circuit. Let's have a look at how this is hooked up and begin to explore. On my breadboard here, or on my workbench here, I've got my battery pack and it's not yet connected. I've got a breadboard that is set up with 3 jumper wires. One for a connection to the red side of the battery pack, positive voltage, a black wire jumper down to the blue rails going to the ground side of the battery pack, and a yellow wire that's jumpered up to a circuit we should all be familiar with now, an LED and a fixed resistor of 470 ohms. I have 2 potentiometers on the right side of the screen here, and we should notice that there is silk screening at the top of the resistor that indicates how much resistance this particular component offers. So this is a maximum of 10K, and the other resistors are a maximum of 500K. Very similar packages, but 2 very different resistances. We're going to work with the 10K resistor in this circuit today. We'll get things ready to go. So as we just mentioned, there are 3 legs in a potentiometer, and we're going to place this into the breadboard. The legs are spaced so that there's actually a gap on the breadboard in terms of tie points, so there's a skipped column in between these legs. And the left leg is going to get connected to the red wire, and the middle leg is going to get connected to the yellow wire, the signal up to the LED, and the right leg is going to get connected to ground. So I'm going to place that on the breadboard here so those connections are made. I'm going to turn my potentiometer all the way to the left, and I'm going to plug my battery pack, or connect my battery pack. And when I do that, you can see that my LED is already glowing. And as I turn the wiper then from the left leg to the right leg, you should see that the LED dims until it's off. And when I turn that wiper in the other direction, the LED now glows brightly. So this component allows us to explore a very different set of relationships in the world of electricity. Up until now, we've been able to turn LEDs either on or off, and we could change their brightness by altering their fixed resistor. The potentiometer gives us the ability to change the voltage in a continuous way, and we get to see now not just an on-off digital adjustment, but an analog adjustment to the brightness of that LED. So those are the basic hookups, and it should be enough to get you started in exploring with your potentiometers.